Good morning, world. I'm Bailey Howe with Channel 8 News with my co-host, Brooke Walzer. We have wars going on all over the world, but the most important one we are fighting right now is a war on bacteria. Bacteria outsmarting us. Every day they grow better at evading the drugs we deploy against them, and new molecular weapons are getting harder to find. The gap between our arsenal and bacteria's ability to resist it is now so wide that the World Health Organization issued a report earlier this year warning that we could find ourselves in a post-antibiotic era. A post-antibiotic era would place the world of medical care back into the Stone Age with the possibility of minor scratches turning into deadly diseases.
That's right, Bailey. From the year 2000 to 2014, just 9 new antibiotics gained Food and Drug Administration approval, which is also known as the FDA. By comparison, 20 were approved from 1990 to 1999, and 43 were launched in the decade before that.
That's good stuff, Brooke. We have several scientists that we will be hearing from today, starting with Dr. Boucher, an infectious disease expert at Tufts University School of Medicine.
Dr. Boucher here from the Tufts University School of Medicine. We know that the current pipeline of antibiotics is not sufficient, and that we need more antibiotics for both gram-negative and gram-positive bacteria. Gram staining, pictured above, is a scientific process that allows us to determine whether something is gram-positive or gram-negative in reference to bacteria. Gram-positive, labeled here, has a thick peptidoglycan layer that allows our antibiotics to attach to it. While on the other hand, gram-negative bacteria has a lipopolysaccharide layer above the peptidoglycan layer that prevents antibiotics from attaching to it. Back to the studio.
So I assume many of you watching this are probably wondering how the scientific and medical community are going to fix this problem. Well, the general consensus points to 3 major fronts where battles need to be won in order to refill the antibiotics medicine chest. Clear and reasonable expectations from regular authorities on the data needed to prove an antibiotic, better approaches by researchers to finding new treatments for bacterial infections, and a willingness by the public to value new antibiotics in a way that rewards innovation.
That's true, and some of the biggest problems we are having is not the lack of new antibiotics and new research, but instead the Food and Drug Administration having many requirements and unrealistic expectations for drugs to be approved. For example, worm therapy has been shown to relieve those with Crohn's disease and other inflammatory bowel disease, but the FDA requires many clinical trials and has yet to approve the new type of therapy despite its results. To learn more about the FDA approval process, let's send it out to our FDA expert, Lee Brackman.
FDA expert here, Lee Brackman, to discuss the FDA approval process for antibiotics. Phase 1, we are going to have preclinical trials on laboratory animals such as rats. In step 2, will be broken down into 3 phases. The first phase will be determining the side effects on humans. In step 2, we will determine the effectiveness of these drugs. Effectiveness will be determined on about a dozen to 100 subjects, and we'll also be looking at the metabolization and the excretion of the drug. Step 3 of step 2, if that makes sense, will be on a larger scale, probably around 300 to 400 people. And finally, step 3, our sponsor will take the antibiotic to the FDA for approval. Thanks, and back to the studio.
Thanks for that, Lee. A perfect example of this process can be seen in the drug dalbavancin, an antibiotic for the infectious disease of MRSA that took 18 years to be approved by the NDA and the FDA. This drug could have been on the market in half the time if the approval process was more streamlined. The drug traded companies and went through several approval processes after it had already been determined to be safe and effective.
That's a good point, but the FDA does need to be careful before they approve any antibiotic that could possibly have deadly side effects. In order to better understand this process, we are going to go out to our last scientist, Carol Modersky, to talk about how bacteria becomes immune to antibiotics in the first place.
Typically, there is 3 ways of resisting: genetic mutation, natural resistance, or one species gaining resistance from another. All of these are essentially natural selection in practice. A few strains of bacteria are not affected by the antibiotic, and thus are the strongest, and the strongest survive and reproduce until the entire population is immune to the antibiotic. Thanks for listening.
And let's not forget that creating an antibiotic is not the easiest thing in the world. By the time you create something suitable for that bacteria, the bacteria has already changed its form, rendering that antibiotic ineffective because of the long approval process. For that reason, many companies are not targeting the antibody directly at the pathogen. Instead, they are focusing on neutralizing bacterial toxins, which damage tissue and prevent the immune system from sweeping away the bad bugs.
With all this information, the FDA and NDA are working on streamlining the approval process in order to bring antibiotics to the market quicker. The scientific and medical communities are also approaching bacteria in a different way, with new ideas in order to win this war on bacteria.
Thanks for listening to the Channel 8 News. We'll see y'all next week.